Hello my dear students, welcome back. In the series of learning programming in C, in the previous video we have started with introduction to arrays. So we have seen what is an array, the advantages and disadvantages of arrays, and we have seen how to declare an array. Well, in today's class we will see the different types of arrays followed with how to initialize the one-dimensional array with an example program. So let's get started. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the videos till the end so that you can have a better understanding of the complete topic. And if you like the video, please click on the like button and share the videos with your friends. So before we get into the initialization of array, let us see the different types of arrays. So we have three types of arrays: one-dimensional array, two-dimensional array, and multi-dimensional array. Well, in today's video, we will be starting with one-dimensional array. We will see how to initialize that one-dimensional array with different methods, and with an example program, we will see how actually to use this one-dimensional array. So let me give the gist of all these different types. One-dimensional array. Dimension specifies size. So as discussed earlier in the previous video, we have understood what is an array. Array is a block of memory that can store elements of similar type. So it is a homogeneous collection of elements. When I say it is collecting elements, means it is storing elements, n number of elements, I need to mention how much elements it can store. That is what the size or the dimension specifies. So here when I say providing dimension, it can be a one-dimensional or two-dimensional or multi-dimensional, in the sense we provide one size, two size and many size. But what actually these sizes is going to deal with? So let us have a small gist on this. In detail, we are going to discuss about all these different types with example program in the next coming videos. So one-dimensional array. So one-dimensional array says it is having only one dimension, and that size, that is dimension, specifies how many number of elements the array can store. That is the number of elements that what an array can store. Then talking about the two-dimensional array, here we are going to provide two dimensions. So where we use this two-dimensional array? So when I want to represent my data in the form of rows and columns, in the form of table. So when I say I have many rows, many columns, I need to provide two details. One is the row value and the other one is the column value. So two dimensions I need to specify. So in such cases, I use the two-dimensional array. So where we use this, especially to represent matrix form of data, I use this two-dimensional array where I want to represent the data in the form of rows and columns. So I need to mention both row and column value. So it is two dimensions. So row, see for example, if I take this only, so you have 3 rows and 3 columns. So it is 3 cross 3 according to the matrix representation. Totally it can store 9 elements. So that will be the total size of the array. We'll discuss about this in detail in the next coming videos. Next, multi-dimensional array. Multi means many dimensions. So when we deal with some graphic objects, we have to look into the graphical object in different dimensions, in different angles. So then we have to take care of many dimensions. So we use this multi-dimensional array when we have to represent some graphical objects. So this is what with the one dimension, two dimension and multi-dimensional. So multi-dimensional means it is specially used for graphic objects. Then this is for matrix. And this is for normal values, set of values. When I want to store a linear fashion of data, linear format of data, I go with 1D. If I want to store matrix, I go with 2D. If I want to deal with graphics, I deal with multi-dimensional array. So let's get into the first type of array, which is one-dimensional array. So here we go with the initialization of the one-dimensional array. So we have totally 4 methods to initialize. So let us see the first method of initializing the 1D array. So we have the array declared as marks, and the dimension that what I have given is 5. Meaning to say it can store maximum 5 values, not more than that, but it can be less than that. Now I am initializing that value. So to initialize the values, we have to use equal to, flower brackets and semicolon at the end, and a set of values separated with comma operator. So I have given 5 values and I have separated with the comma operator. Now, as soon as the compiler encounters this array variable declaration statement, what it is going to do? It is going to allocate the memory for that, depending upon the dimension and data type. So dimension is 5 and data type is int. Means to say, to store one integer value, if I talk about the 16-bit machine, it requires 2 bytes. So totally 5 values I need to store. So it is 5 into 2, 10 bytes of memory it has to allocate. So assume the memory has been allocated from 101. So totally 10 bytes means 110 to store 5 values. Each requires 2 bytes. So I have given this memory representation also. This is what the memory representation of arrays. So this is the memory representation of one-dimensional array. So the memory is getting allocated to store 5 values of integer type. To store one integer value, I require 2 bytes. Totally 5 elements means it is 10 bytes. Let us assume the memory has been allocated from 101. To store one value, I require 2 bytes. So it is 101, 102. So the address of the first element means it is 101. So it is stored in the index value 0. Every element that what we store in the array will be associated with its unique index value, and that index value, or what we call it as subscript value, always starts from 0. 0 to n minus 1. So I say I want to store 5 values, means it is 0 to n minus 1. So n is 5. So 0 to 4. This is how we can represent. So marks of 0, 1, 2, 3 and 4. Marks of 0 stored in 101 and 102. So what is the address? It is 101, just that's it. Marks of 0, it is 101. 1, it is 103. 2, it is 105. 3, it is 107. 4, it is 109. So if I say what is the address of marks of 3, it is 107. I just can't say 107 and 108. Of course, it takes 2 bytes. I have to specify only the starting address. So it is 107. What is the address of marks of 4? It is 109. What is the address of marks of 1? It is 103. Marks of 0, it is 101. Where 101, we call it as base address. This is the starting address, or what we call it as base address, which is nothing but the address of, it is the base address which specifies the address of first element. This is what the memory allocation. So let us fill those values now. So I have 95 filled in marks of 0, 98 in marks of 1, 85 in marks of 2, 87 in marks of 3 and 84 in marks of 4. So this is how the memory gets allocated and how I can initialize the values. So initializing means giving some constant values to the array. Well, we can also take the values during runtime also. That we will see later. So next, this is the first method. We'll see the next method now. So here we have declared an array of integer type, marks of 5. But in the initialization, just observe, we have initialized only 2 values. The array says it can store maximum of 5 values. So what I said in the previous class, please remember, see whenever we have the array declaration done with some dimension, it's not that we have to completely use it. We can use less than that also, but not more than that. So I say 5. 5 is the maximum size, but I have given only 2 values. So what happens? As usual, as soon as the compiler encounters the array variable declaration, it is going to allocate the memory. When it comes to initialization part, it is going to fill only 2 values. So here I get 95 in marks of 0 and 98 in marks of 1. The remaining blocks will be filled with 0. This happens only when I initialize like this. If it is float, then it becomes 0.0. If it is float. If not, it is 0 for integer. Double again in the fractional method it is going to store. This is the second method. Filling only required values. The remaining memory blocks will be filled with 0 if integer, 0.0 if float. This is the third method. So let us see. Look at this dimension. I have not mentioned the dimension. So I just call this type of an array as unsized array. So what do we call it as? We call it as unsized array. Get the point? Unsized array. So I am not mentioning the size, but I'll give the values. So what the compiler will do? According to the values I initialize, the values will be filled and the memory will be allocated. So I have initialized 5 values. So I'll get the memory to store 5 values and the values will be filled respectively. So 95, 98, 67, 85 and 99. So here we go with the next method of initializing the 1D array. Look at this example. I can mention the size also here. I say marks of 5 fill with 0. Within floor brackets I mention only 1 0. It means to say the compiler will get to know that it has to fill how many zeros? Depending on dimension, it is going to fill zeros. So it says you have to allocate the memory to store 5 values. 101 to 110 the memory allocation will be done as soon as the compiler encounters the array declaration. Followed with that I have an initialization saying that you need to fill 0 to all the memory blocks. So here when I want the default value like this or an initial value to be filled into the array like 0, I can do this or use this method. So these are the different methods of initializing the one-dimensional array. So that's all for today's video. See you in the next video. Well, stay tuned to my channel. In the next coming session, we will discuss about the complete program on one-dimensional array, like how to initialize and print and how to accept and print. See you. Take care. Bye-bye.